lesson. Okay, I think that should be going now. Yeah, I think it should also tell you. Yeah, it will tell you in the participants one that I am, so just so you're aware there. I can put that one down. Now, let's get into the actual lesson. So, can you remember where we picked up off last week?
We did the
Let me get that one up.
We were doing the clock, but I'm not sure where we stopped.
Okay, so this was where we picked up off last week. So when I run this one, you will see when it loads, there we go. All we had was a really quick drawing circle followed by a line which disappeared after a second. Now, do we know why we had that line appear for a second then disappear?
Because it was a second.
Yeah, so it was a second. It's the second hand, and we're sort of simulating drawing a line, and then if we get rid of the line, and we draw it at a different spot, but we do that really quickly, it'll give the illusion that it looks like it's moving, just like I have in this one here. When I run this one, so let us see this, you'll see it sort of looked like it moved in that first one. Now that was only 1 point, which was what I was, so I won't show you how I did that yet. I'll find out. Did you happen to try this one out yourself? Just give me a second. I'm just going to turn on the light. Yeah, it's a bit better. So did you happen to give this one a try yourself to see whether you could get it from going just that first line to the next line?
I actually forgot to do it, but I think I know how to.
That's fine. No, that's that was more just a if you wanted a challenge if you wanted to keep on doing a bit of coding while we were there. So how would we do that?
I think I did the second.
Okay, so you've done 2 seconds?
Yeah.
Oh, fantastic. How'd you do that one?
Oh, I made it so the pen, it first undoes the first second.
Yep.
And goes back to the center.
Yep.
And then and then turns 6 degrees and draws
draws another one? Great. How did you work out that 6 degrees to turn?
360 divided by 360 divided by 60, I think.
Yeah. Okay, and we'll work out, and the reason for that is there's 360 degrees in a circle, but we only want to split that up into 60 points. Remember how if we wanted to split up this circle into 4 points, one there, one there, one there, and one there, we would go by 90 degrees, and that's 4 points. So if we went 360 divided by 4, we'd work out the angle we've got to turn. So if you go 360 divided by 60, because there's 60 seconds in a minute, then we're going to have the angle. Now, you'll see in mine, I just put that in there because it's happy to do that. The reason I've just put this one in instead of putting 6 is because it's only run once, so it's not going to, it's fast enough to do that itself. So, if you were running this many, many times, which, funnily enough, a clock will be doing, it's going to be continuously turning, we wouldn't necessarily want this because every time we loop over, we've got to calculate that again, but we know it's never going to change. We know it's 6. So like you had there, I would replace that with 6. Great. So let's get on to actually making this into a clock that can tell me the seconds. Pardon?
I actually set the 6 to a variable.
Oh, that's it. Yep. So that's a perfectly good way to do it, because then you can tweak it, and if you're using it later, maybe you have a minute hand, and you want to change, you for some reason want your clock to tick 30 points rather than 60 points, you could easily change that. So that's where variables are great for. Right up here, I've got radius written a few times, but I only ever had to type it out once. So if I need to change it, I don't need to look through and go, oh, okay, change that one, maybe forget that one and change that one. I won't have the right numbers because I didn't change all of them. So good thinking there with the variable. We can use that one. So how what's the first thing I'm going to need if I want to get this one to continuously turn 6 degrees and draw a line, like a clock?
You need to keep making it so it undoes and then goes backward and then goes forward.
So basically, we just need this little block of code to just keep on running, don't we?
Yeah.
So how do I do that? What's the one we'd use just to keep something running forever?
A loop.
A loop, and which type? Remember, there's two of them.
While.
So we've got a for loop and a
while
loop. So to do that, we just type in while, and because it's a forever, it's going on forever. We're just going to put in true there, meaning while whatever's inside the indent is true, keep on running this code. And because true is always true, this will always run. So make sure you indent them as well. If you don't happen to indent one of them, it won't be included in this forever loop, meaning essentially it won't ever get run, because once you break it, it would only get run after you break this break out of the loop, and because you never break out of the loop, it won't happen. So make sure you are careful how you indent those, and let's just try that. We might as well see if that works first before we move on. Let's just give it a go. And look at that. We've now got a functioning clock. If I open up the clock down here, okay, that's probably not going to really work, but you can sort of see it's moving at the same time. If they were timed up together, they should change at the same time. But you can sort of see there's the same gap between each when it moves each time. So we can validate that that one's working. Now let's go over and quickly. Oops, don't worry about the error over there. That was just because I closed it while it was while it was halfway through this. Now let's go and work out why this is working and see if we can make this code look a bit better before we move on to making a minute hand. So right here we have a clock, and we create that with turtle.turtle, same as we do with everything else. And that clock, then we set the speed, so we increase it so that we don't notice it drawing. Because remember, if you'll remember that turtles are pretty slow when they're normally made. You can sort of see them moving and drawing the line. If we bump this speed up, and I reckon it's going to even be better just to increase that to 100, because why not? You shouldn't notice it drawing, or you won't notice it drawing. And one other little thing, didn't even look, we have it commented here. If we hide the turtle, we now no longer have to actually see what's drawing it. It just looks like a clock. That's just going to keep on going forever. So we've got what we wanted, what we set out to sort of do, but we can make this better. And that's with a minute hand, but we need to go and think of how we can actually add a minute hand before we go and change this. So I realise we've got to do this before we change this. So if I have a turtle that can draw the seconds, we only need to know that from wherever it is, it needs to turn right 6 degrees, don't we? It's always going to do that. It's never going to do anything else to just draw those second hands. Yeah? You agree with that?
Yeah.
Yeah. So we always know that it's simply whatever angle it's facing right now plus 6 degrees. I wonder if I can actually. Yeah, I'm just going to draw this, but I'm going to get rid of the for loop just for a second. Actually, no, I don't want to undo it. Just so I have a graphical thing to explain this. So there we go. Now, it did the one turn like I expected, and then it didn't go away. So we have a plain clock to work with that has a second that goes every 6 degrees. So we know right now, 1 second, I'm going to actually not hide the turtle so we can also see that. And we're going to go 60 degrees instead of So that's 60 times 6 times 10 is 60. So that's 10 seconds there is what we're at now. So you can sort of see where the turtle is right now. It's pointing that direction at 60 degrees. What's the angle it needs to point at to draw the next second?
The 6 degrees.
66, did you say?
Yeah.
So we're at 60 degrees now. That's our angle. That's our angle from here. So we've already rotated 60 degrees around this circle. We're at 10 seconds, and we want to go to the next second. What's the angle we'd turn to?
66.
66, because it's just 60 plus 6. We're always adding 6. Now, let's say we had a minute hand now, and we were trying to draw it with the same turtle. On this first minute, where does the turtle need to be facing, pointing? So only 10 seconds has passed, which means a full minute hasn't passed, so that turtle should be pointing up.
Yeah.
To get there, we now need to go back, turn negative 60, draw up, somehow undo that without undrawing the hand, turn 60 degrees back there, and then redraw the second hand, which, I don't know about you, but that's a bit confusing. Like, that sounds way too confusing. And because of that, let's go and find a way to not make that confusing, because even explaining that, it doesn't make too much sense doing, because then we've got to keep track of where the minute hand is pointing and where the second hand is pointing. We'd have to put in a few more variables, and I don't want to do that. Let's go and try out making 2 turtles. So I'm just going to copy this line, and we're going to change this to, okay, there's 2 ways to do this. We could go with 3 turtles, one to just draw the clock, one to draw the second hands, and one to draw the minutes. But I'm going to keep this one here, drawing the seconds and the clock as well, like we already have, and just introduce one for the minute hand. So do you see what I've done there?
Yeah.
You know what this line does?
It creates another turtle.
Yep, and that turtle has a name Minute. So right now, Minute doesn't do anything. We don't even reference it at all. But we reference it exactly the same way as we would for this turtle, for this clock. We just go minute dot and tell it what to do. So let's think of when we start this program. I'm just going to, I don't think they show when they're initial. I think they have to move to show, but we'll see in a second. Okay, no, it is there. So see where it starts? It's pointing to the right. That's not where that's not where the minute starts. A minute starts at the top of the hand. It starts at the start of the hour. So we need to turn our turtle at the start to face upwards. We need to face it up. We have to do the same thing for the second turtle. So let's go and just, when we turn the turtle to face upwards, remember that was here? So we go to the center, and then we set the heading to 90. Do you remember why that's called 90? Why the number's 90 that we put there?
Because 90 is up.
Yeah, because this is 0. This is where it starts, and positive angles go this way on the circle. So if I said positive 45 degrees, we'd be up here, because that's 45 degrees. So if I say positive 90, we'd be up here. Now, if I said to you, go to 270, where would I be?
You would be where?
So we've got 90, 180, sorry, and then 270.
Okay.
Now, that was a bit of a trick one, because I could have also said negative 90, and you would have known that a lot better, wouldn't you?
Yeah.
You would have known exactly where that was, because it's just the opposite direction. So like I tried to stress before, if we get to 180, we switch signs. So we now go from this direction. So instead of having to go to 340, I can just say go to negative 20. So 340 is right around this circle, 180, 270, 340. But negative 20 is just 20 this way, which is right there, the same spot, because it's 360 minus 20. So with that, that was just a pointer out of why we use the 90 there. And if I said negative 90, it would go the other direction. Now we want our minute hand to also face upwards. So we're going to, right after we send our turtle to the center and set it to 90, we're going to set the minute one to 90 as well. Minute dot set heading 90. And that's just 2 angle, tells you exactly what it should be. That's the angle it's going to turn to. Now there's another way we could do this. Can you think of what that might be? So we know where it's pointing when it starts. It's always going to be pointing there. What's another way I could get it to look up?
You could just turn it up.
Yeah. So if we think about it, if it's looking this way, pretend we're the point. We're looking at this way, and it's top down. So we're facing that way. If we turn to the left, that would be turning this way, wouldn't it? That would be going from this way to there. Yeah? Do you agree with that?
Yeah.
So that's a bit of just a spatial awareness thing. It can be hard to sometimes picture which way it is when you're not directly looking in the same way. Just like in a mirror, if I said left, it would look like the right's going that way. How it flips everything. You just got to picture where it's looking from, and it will make sense. So this one's going left, and how far to the left would we turn?
You would turn 90.
90. So exactly the same, because we're already at 0. So 0 plus 90 is 90. So that's another way to do it, but just because we've got the other way here, we will just go with that one. But note, either way is perfectly fine. Now, when I run this again, this turtle will now be pointing up. What do I want that turtle to do now? Can you think of what I might want it to do?
You make it so it makes a line up.
Yep. Great. So we're going to do that the same way we did it with this. Now, what I'm going to do, we will draw these lines first. Actually, let's just put it all in the same loop and then see if we run into any troubles with that later. Make sure. So I'm going to take... Actually, no, we do... I can't remember if it's fine to go that. So let's think about what's going to happen when we start this program. This is going to draw the circle. So let's put in a comment just to say exactly what this is doing. All this block of code. So I'm just going to, so it's really noticeable. This block of code draws the clock. And now this code down here resets the turtle. So all this one does, draws the clock, so we put the pen up so we can move down to the bottom, and then we draw the circle, and then this one puts the pen back up so it doesn't draw a line back to the center, goes to the center, faces us up, and then puts the pen back down so we're ready to start drawing. So this resets the turtles, because it does it to both of them. Notice how I don't just set the clock to 90, I also set the minute hand to 90. So this block of code resets the turtles, and this block of code draws the clock. Or not draws the clock, sorry. Yeah, that one draws the clock. This one down here, however, draws the hands. So this one's going to draw the second hand and the minute hand, and this one's just going to keep on going forever once we set up the clock, because the clock never changes. So We now need to bump this one back down to 6 because we want to go at a second, not at 10 seconds. So there you just change your variable to the degree you want it to. And we now need to just start working out how we move the minute hand. So let's redraw this so we can see where we're at now. 1 second. It takes its time to load here. And right now, you can sort of see we have 2 turtles going here. It's moving too fast. We can't see that line being drawn. We can see it sometimes flicker down here, but we're not going to see that when we hide it. But it's moving so fast we don't see it getting drawn. So that's what we want from the second hand, but the minute hand doesn't do anything. The reason it doesn't is because we haven't told it to, and that's what we're going to do now. So, if you think of a standard clock and the second hand, how big is the minute hand compared to that, roughly? Like, I don't know the answer to this. I'd probably go it's about a half, maybe 2/3. Yeah, probably about 2/3, because remember the second hand's usually the real thin one, or sometimes not even on a clock. So, we want to draw a hand that's 2/3 the size of this. Do you, so you're aware with fractions and percentages?
Yeah.
Yeah, so for 2/3, that's just right there. Picture that's 1/3, so it's sort of moving, so bear with me there. That's 1/3, and that's 2/3. So that's about how big we want the minute hand to be when it's going around the circle, about up to here. Now, we could work that out by hand. We could say, oh, the radius is 300, so let's go and move the minute hand. Move the minute hand forwards. So what's would you know what 2/3 of 300 is, or how you could work that out?
I forgot.
So first, do you know how to find a third of this? So we just divide this by 3. If we divide 300 by 3, that's just 100. And then that's 1/3. But we want 2/3. That's only this distance. We want 2/3. So what would 2/3 be if 1/3 is 100?
200.
200. So we could go here. We could go forward 200. Time dot sleep. Minute dot undo. Bear with me. We're going to also be changing this. This isn't how we're going to be doing it, and you'll see why in a second. Now when we go and do this, how many minutes are in an hour, by the way?
60.
60. So that's the same as seconds, essentially. So how far would we need to turn for 1 minute?
60 times.
Yeah, so we're going to need turn 60. Okay, I phrased that badly, sorry. How many degrees would we need to turn for a minute?
360.
360? Okay, for an hour we would. That's how once we've done 360 degrees, we've had an hour. But how many for one individual minute does the minute hand need to turn?
6.
6, yeah. So exactly the same as the second. So no difference there. And let's just, I'm just going to copy all of these. And then just replace it with minute. Just because I can be, it's pretty easy to be lazy with the code and just change variables, especially if they're doing the same thing. And that's the great thing about having variables is I'm able to do that. I can just copy all this block of code and do the exact same thing for the over and over again, really easy. And we've got 2 turtles now doing the same thing. So when I run this, will this work for me? Will this draw me a minute hand?
Yeah.
Yeah, so it will draw me a minute hand, but will it move it a minute?
No.
Let's go and have a look. Let's run that one. There we go. Oh, for some reason I forgot to put the amount that we're actually going to be turning, and that's going to be 6. So you can sort of see, like, once you sort of get used to errors, you can read exactly what's doing. You look at the line, you can see, oh, it's line 43. Yeah, I don't know if you can turn line numbers on in here, but in most other editors, which I'd definitely recommend using, you can have line numbers there, and it will tell you exactly the line to go to, and then it would sort of almost tell you what it is. Some of them can be a bit cryptic, but right here it tells me right, missing one required positional argument, and that's the angle. And if you had a look over here, my minute dot right on line 43 didn't have it didn't have a positional argument called angle, and it needed just the one, just like it says. So once I fix that one up, let's now retry it. And the reason it actually did draw and start running everything, nothing actually came like to an error. I'll show you what I mean. Notice how, even though there's an error in my code, the code still runs and the clock still draws, and the second even tries drawing, and it's only when it comes to turning that we get an error, and then the stops, nothing else happens. What that is because this goes in order. It runs down line by line by line by line by line, and notice how it was 43. So it's a lot of lines to go through before we actually hit the error. It doesn't check your code before you, so that's a big thing to look out for. Again, in other editors, that will mostly be like highlighted or something. It'll tell you that there's an error because they check it, but this one's the really basic one. So with that out of the way, let's draw this. Now, can you sort of see what's going on? It's a bit difficult to work out exactly what's going on, but can you sort of see what's happening? So we're drawing a second hand. Like we've said, let's put this over to the side so we can see the code too while we're looking at it. So we're drawing the second hand. Remember, that's the clock one. And we're drawing the minute hand. Great, no problems there. We sleep for a second, and we undo, and we undo. Now, if we think about what we know, that should be fine, because that was working for the second hand, but we're getting this weird bouncing effect. Do you know why that might be?
The undos.
Okay, so it could be, it's the undo, I don't know whether, okay, yeah, so undo literally undoes that at the same speed. So it doesn't look like it's the undo, but what we can sort of see is it sort of looks like it's the second hand bouncing here and then bouncing back, but it's actually not. That one's doing everything we wanted. If I got rid of the minute hand right now, we would go back to having a normal clock. The reason is I haven't changed the minute hand at all, the second hand. It's like I didn't actually touch any of the code that involved the clock. The reason it's doing that is because we only set the second hand speed to 100. We never set the minute hand speed to 100, so it's still at speed 1. And as you can see, you can notice it getting drawn there. So we need to go minute.speed 100 as well.
I have a problem.
Yep, what's your problem?
I've copied your code, right?
Okay.
I haven't done the minute speed yet, but everything else is to yours, and it says something like the turtle is not callable.
The turtle is not callable. Okay. Have you imported turtle? Have you got these two ones up there?
Yep.
Yep. Okay. Okay. Well, how about I will switch. Oops. Again, another error. I will stop this share, and if you want to share your screen, and I will go and I will look over that and see if I can find what that error is. Just give me a moment. There you go. If you want to share that one for me, and I'll see if I can find what that might be. And then having like another drawing programs, like editing program that actually tells you the lines, makes this kind of stuff a lot easier as well, because you can sort of say, oh, on this line, fix this sort of thing, or it's that. But for now, okay, where'd that go?
I did the wrong one.
Okay, it's all good.
See.
Okay, so
I have to check.
turtle object is not callable. Okay, looks like you might have done a capital letter where it shouldn't be. Oh, that's a type object, and a turtle is a lowercase. So if you want to go back to, actually no, they're not. If you want to go back to the actual code, and I'll look over that. So that's line 40.
Okay.
And
This is
yeah, if you just want to share that one.
Okay.
Okay, so we've got line 40, so that'll be down in this loop somewhere, or just above it. Okay, min-turt. Can I see where you've named your turtles? So right at the top, where you made them. Okay, so we've got min-turt and clo-turt. So a lot of these times you can try and just sort of check over names and make sure. Like if you select, if you highlight so if you highlight one of the names, it should highlight that variable. Okay, sometimes they highlight all the variable names of the same type. Line 40, where would that be? That's down about. Turtle object is not callable. Oh, right, min-turt. So see the third line in your while true loop? Right down there, min-turt. So yeah, you've got min-turt, but no dot there. So you're not calling the method. No, that won't do that yet. We've got to see what you were trying to call there. So what line did you want it to actually do there? Because right now, all it's doing is it's going min-turt, which is the variable name, dot turt turn, which doesn't make too much sense in the computer's eyes, so it's given us an error. What were you actually trying? So that's the degrees, so you wanted to turn it to the right. So you've got to type in right there, just like you have on that first line in the while true loop. Just missed out the actual method's name. So once you run that, you should get that one. I probably won't be able to see it on the screen because it's a screen one.
Now it's showing this one.
Now it's showing. Okay, so there might just be another one. So we've got a variable that we haven't actually made, so it just doesn't know what we're talking about. So name errors are usually pretty easy to fix. It's just a spelling mistake, or you've forgotten to rename a variable that you changed.
Yeah, I think I know what it is.
Yeah, so name errors are nice and easy to fix up. They're just literally a name error, like the variable name is wrong. Some others can be a bit difficult, but other than that, let's switch back over and continue on. I don't think... Yeah, so if you want to stop the screen share, and then it should switch over to mine, I believe. Because I don't want to start a screen share on my screen and then it be sharing both screens and just make a loop there. Okay. So, with that done, let us see where we were again. So we've bumped the speed up to 100, so it's at the same speed as the second hand. So we shouldn't notice it turn now. And now, funny thing is, we can't see the minute hand, and it's also turning at 6 degrees a second, which it should be turning at 6 degrees every minute because it's a minute hand. So we need to slow that one down. We need to work out a way to slow that down, and we also need to work out a way to differentiate it between, because we can't tell if it's a second hand or a minute hand. It's not going to make too much of a difference in there, but it will look a bit better. The way we do that is we just go minute dot, there they are, and if we scroll down, you will see pen size. So if we go pen size and we put the brackets, it'll tell us the width equals none. Now I'm pretty sure that defaults to, I'm pretty sure none means 1. So maybe let's make it double and see what it looks like. See if we can tell them apart now. So we just put in the size, the width of the line, and see if that one changes it enough. Okay, I'm happy with that. If that looks all right, but notice how it disappeared. So the reason we couldn't tell it wasn't there was because it wasn't there. So we need to fix that. Now, what's happening here is in our true loop, we're turning to the right. So we've undone these. We're at the center and we're turning to the right. We turn them both to the right, but then we only draw the clock forward a second. we only draw the clock line, and then we wait a second, which is what we want. We want the line to be there for a second. But then we come out of that 1 second, we undo that, and then we draw the minute hand and get rid of it straight away. So that was an error on my part. You've got to put the forward before the sleep, before you do the sleep. So that way it's there for a second. But again, doesn't fix our problem of it disappearing every second rather than a minute. And that's what we'll fix now. Oops. Because I copied those lines, you've got to be careful. I'm drawing the minute hand forward radius there. But brings me back to my point before of we could work it out by hand. But then what's the point of having the variable up here? Because if I change this to 400, the clock will be bigger, the second hand will be bigger, but the minute hand will now be half the size because 200 is half of 400. So it doesn't change accordingly. So there's no point to really having a variable there if we're not going to actually use it. So to get 2/3 of a radius, I just go radius times 2 divided by 3. So that's what our how far our minute hand is. So that's the minute hand length. Now I'm going to do what you did before, and I'm going to actually take this out and I'm going to make a variable for it, because I don't want to be computing that every time I draw the minute hand. So all I'm going to do that is minute length equals, and all it means is this is going to be a number. So far it's going to be 300 times 2, which is 600, divided by 3, which is 200, like we had before. And then I'm going to put that variable in here and use that for that. Now, if I change radius to 400, this will be 400 times 2, which is 800 divided by 3, so it comes out to something like 250. Yeah, it doesn't really matter what it is because it will work it out for us. That's the whole point of this. We could put in 322 and it would work it out for us exactly to where we want it to be. So no point making a variable if we're not going to use it. So let's copy that one down to this one as well, because that's why we have a thick line there rather than a second and a minute. Now again, we'll close it. Just ignore those errors. Like this one's, that's part of the actual graphics. When we close it while it's still drawing, it just creates an error. Okay, cool. Reason it disappeared then was because I was moving the window. You'll see it doesn't actually update when I'm holding the window down, only when I let go. So, these ones, we now have a minute hand that we can tell apart from the second hand. We just now need to slow it down. So let's think about this in a logical manner. So that way we can come out with a good answer of a clear focus of what we're going to be coding. So our second hand moves every second, yeah? And that moves 60 times in this clock. When it does that, how many minutes have passed?
One.
So 1 minute has passed. So every time we hit 60, every time like we've done 60 turns, the minute hand has a turn, doesn't it?
Yeah.
So that's exactly what a clock is. So if we had a clock image, that's what it would do. We would have just rotated 1 minute there because that was a minute past. But it would stay there. It wouldn't go and update like this. So we need to work out a mathematical way to say, okay, if we've done this 60 times, go and move this one. And that's all we want to do. Every 60 times, just keep on moving the minute hand forever. Just keep on doing that. And that's all it's got to worry about. So when you think about it, it's not a really difficult problem. We just need to work out how we can actually tell when 60 seconds has passed. And to do that, the way we're doing it now, we can't actually do that. We don't have any way to just quickly say, oh, is it 60? Okay, then turn. To do that, we have to keep track ourselves. Now, if I make a variable, and I'm going to call it timer. timer's just going to be set to 0. Sorry, Java. Timer's just going to be, okay, I thought that one just stopped working, but it must have just been not drawing. Thought we might have found an error. So I'm going to set that to 0. And this is going to represent one turn of the second hand, so 1 second. But to do that, can you think of how I can actually make this represent 1 second?
I'm not sure.
So if we have a look through our thing, we've actually got something that waits a second. So remember, this all happens super fast. Like, the computer runs this as fast as it can. This is just telling it, well, slow down. Like, you're going a bit too hyper for me. Slow down. I need to know exactly how long has passed, and I need this length to pass, which is 1 second for us. If I just simply add 1 to the timer every time we call time.sleep, do you reckon that would keep track of the time for me?
Yeah.
So essentially, if we start at 0 and then 1 second passes, so we call time.sleep, and then I go timer plus equals 1, what does timer equal now?
1.
1. And how long has passed?
1 second.
1 second. Now if I call time.sleep again, and then I go timer plus equals 1 again, what are we at now for the timer?
2.
And how long's passed?
2 seconds.
2. So there's one key thing we're assuming here. We're assuming that all of this happens insanely fast. Because if it doesn't, imagine right down here, I call time.sleep. 1 second. And then I don't immediately go timer plus equals 1. So this is what I should do. Timer plus equals 1 immediately after that. So that way I know as soon as this second has passed, this will update. But what happens if I waited a whole second and then I did something like minute dot forward? But the people who made Python, they didn't really do their jobs too well. Like this is all made up. This is all pretend, but they didn't really do their jobs too well. And forward takes about 2 seconds to run. It's a really bad thing. It just takes a long time to run for whatever reason. How long would have passed now? If this took 2 seconds and we waited a second here, how long has passed now?
3 seconds.
But we only added 1 to the timer. So we're making the assumption, and I'm not going to do anything about this, this is just one thing to take note of, is we are making assumptions here, and that one is that this one happens in 0 time. If we're saying this doesn't run in 0 times, but it's like 0, 0, 0, like 0.0000001 seconds, so it's not really meaningful. But if this doesn't take 0 seconds, the timer doesn't represent the seconds, and everything that we've been working towards doesn't count for anything. Because if we're moving this second hand every 2 seconds, that's not really a good clock, and we've failed with our design. So let's go, and now that we have a way of keeping the time, let's go and work out how we can use that timer to go forward. Now, first of all, I'm pretty sure I will be able to put this in the loop, so I'm going to do it straight away, just so that we can, so that we don't have to have all this code up here that's not needed. So I'm going to separate these into blocks of what they're doing, and notice how for every clock that I'm doing something with the other one. Well, that's what we've got to change. We only want, I just cut that so I didn't actually delete it. Oops. We want this one to run every second. We only want this one to be every 60 seconds. So pretend that this code isn't here for a second. Only these two. But I think I want to keep them for a second just because we may use it in this block, in this loop. So we have timer equals 0 declared out here. So we can use the timer now. We're free to go and use our timer. I'm going to move this up here. So the first thing we're going to do in this loop, is it going to be... First thing we're going to do in this loop isn't actually turn right. It's going to be Okay, we do need these ones out here. That's what I remember. We do need these out here. So bear with me on this code, and we'll tidy that up in a second. But in the loop, just pretend we've waited 1 second. We've done what we did before, how we drew the line, waited a second, and then undid both of those, just like we do here. We draw the lines, we wait a second, and then we undo both of them. So we're both at the center, pointing up, waiting to be turned to go and draw the next one. But first of all, we don't want the minute hand to disappear. We want that to stay there for the whole 60 seconds. So I'm just going to get rid of that. So now we have the minute hand staying there, but this one is... That's not part of our program yet. No, they're not current errors. It's down here. Okay, so see what happened there is let's think about this isn't actually what it's meant to be doing. Obviously, this is still drawing. I should have commented out this line here. The thing about this, when we first run the loop here, we draw the second hand up there. So the second hand's right there now at the start of the loop, and the minute hand is right there, as we can see. Then we wait a second, but then we only undo the second hand. So the minute one's still up there waiting to, like, showing us a minute. So we've undone the second, so it's pointing upwards down here now. So ignore what it's actually drawing. That can be stopped, but then it would mean I've got to get rid of all of these indents, and that can take time. So the clock so the first thing we're going to do in our loop is turn this one a second, like we do here, and then move it forward again, yeah? Are you following me so far?
Yeah.
So we're now, our second hand is up at the first second. Our minute hand's still there. So let's wait a second. And let's do a check. Let's first now add 1 to the timer, because 1 second just passed. I shouldn't have gotten rid of that space. 1 second just passed, so we're going to add 1 second to our timer, like we did just here. Just exactly the same there, just doing it in a loop now, so the timer's continuously going up. And now, what do we want to check? What is the condition I should be checking for? Do you remember?
If the timer is at 60.
If the timer equals 60, exactly. So, I'm going to go if timer equals 60. Now, remember, no brackets around here, like some other languages will put brackets there. That should be right, yeah. And the double equals sign means we're checking if this value, is equal to that value. So if the timer variable equals 60. Notice how, though, up here, we've got 1 equals, and that's just saying the minute variable does equal this, like make it equal this. It's telling it to do something, whereas we're just checking if that's the case. Now, if timer equals 60, what do we want to do?
Make it so it goes a second, second minute.
So it does a second. So in this case, we want to do a minute. So we're going to be controlling the minute hand now. So we've already for this second we've already moved the clock, that one. This we may run into a problem later. In a second, just of these numbers. We just got to tweak a few of these numbers, but I'm happy leaving it for the moment. Then we can see if it works or not. This one right here, when we get to this loop, where will the minute hand be? On this clock, in this first, like we've just had our first minute, and the timer equals 60. So right as soon, on this line, where is my turtle at the moment?
So it's at the first minute.
Yeah, so it's right there. It's literally where it is now, but it's pointing upwards. So first thing we need to do is we need to get rid of that line. So all we're going to do that is just go minute.undo. And that will undo the last command from this turtle, the minute turtle. Won't undo this one though. So it'll just get rid of our minute hand, which is exactly what we want. And with that undone, I now want to turn it right 6 degrees, because that's 360 divided by 60, which is how many points it needs to make. And then we're going to move it forward. That minute length variable we defined up here. Now, can you sort of see why I've now defined this one up here rather than doing radius times 2 divided by 3 here?
Yeah.
Do you get why I did that?
Yeah.
Because every loop, so every loop here, like it's not, in this case, it's not going to make much of a difference at all. Like it will probably make literally no difference, because we're talking orders of seconds. Like if this takes like half a nanosecond to compute, if we had to run that as fast as possible, half a nanosecond can add up if we're computing this thing every, like, as fast as we can. But because we're doing this one, we're not even calculating it every second, we're calculating this every minute. It's not going to make any difference to our program, but it's good habit to take like a complex sum or something with a lot of especially with a lot of divisions in it, and actually and taking them out of any loops, making them beforehand if you can, because we know that this number's not ever going to change until maybe we start the program again and make the radius bigger. If we don't start the program again, this variable will never change because the minute length doesn't change. If I move this program around, if I do however I interact with this, if I make the window, I don't know if I can, I can. Notice how the minute length still hasn't changed? Still hasn't gotten shrunk. So we know that that's never going to change. So we can define it outside of here and be safe in knowing that it's going to be correct. That is exactly what we want every time we loop. So that one's good there. It's just good habit to go and do that. Let's get rid of these ones. And actually, I shouldn't have gotten rid of both of them. I don't know why, but clock dot undo. So what I was just doing there is I was getting rid of that second minute undo that we had down the bottom, because we don't want to undo that every second. We want to only undo it every minute. So every time timer equals 60. But can you see a problem here? I'm not going to go and show you what the problem is because it requires a bit of time to actually see it. And you'll understand once you see it. Can you see what a problem would be with this block here? If we need to do this every minute and time is always increasing. So when we're running our loop, timer equals 0 at the start, and then it equals 1. And it keeps on going up right until it goes 60. And then this line comes true. Like this one just here goes, oh, this is true. Let's run this block. So we undo the minute, we turn it right, and we go forward. So we've essentially moved a minute after 60 seconds. But now we run the loop again. Timer equals 60 plus 1. So it equals 61. Is this ever going to be true again?
No.
No, because I'm always increasing it. So there's one little thing that I need to do to stop that. And can you think of what it might be? There's many ways we could do it actually, I should say. But here's one way. Can you think of what it might be? So, if our timer equals 60, we just want to start it again, don't we? We don't care what second it is, how many seconds have passed after it. We only care that 60 seconds has passed from the top, don't we? I'll show you what I mean by that when I run this. So now we're going to see two improvements. We'll actually see the minute hand in action, and we'll see that little fix there, so it actually does the 2 minutes. And once it loads, there we go. So what I meant, why is it jumping around so much? There we go. Now what I meant by the timer is we don't care how many seconds have passed. There's no numbers on here. It's not an actual number clock really. It's a qualitative representation, which means there's no numbers. There's no actual correct thing. This could be the 10th hour up here, and this could be the 600th hour over here. It's just once we slap those numbers on, it actually means something. These arrows are pointing to something definite. But for now, it doesn't actually matter. So, if 60 seconds has passed, it means our clock has gone, it's done this one, and it's reached here. So our timer equals 60, this one moves over 1. But our second hand's still up here. Then the next second passes and it's at 61. Or, if we go and reset it to 0, it's now back at 1, isn't it? Yeah? So it's at 1 now. So now it's at 1. And see how it works. So it just ticked over. There we go. And that one, and I do believe that actually didn't run into the problem I was thinking. So we're all good there. We don't need to change these numbers. I'll see on one more try while we're explaining that. But this one is now, it's not at like 82 right now. It's at something like 20 because it's only a third. But when it gets to half, it's not at 90, it's at 30. And then when it gets back up to here, it gets back to 60, and this code runs again. We move this one over. But notice how I don't actually care what the time, what second it is from when we started this program. It's not a timer, it's just a clock. So pretty simple there. We don't actually need to keep track of what timer is. We only need it for the purposes of getting to 60. Now, you'll notice here, when it hits the minute, this should turn. Okay, we did run into it. Well, I guess it sort of depends. If you like I'm not sure exactly how all clocks do it, but if your second hits 60, should your minute hand move when it hits 60 or when it goes on to 1? And that's a choice of yours. Notice how when it hits 60 there, my minute hand stayed in the same position until it moved to the first second. Did you see that?
Yeah.
Yeah. To fix that, all you need to do is make this wait until 59. So just 1 second before instead of well, actually no, this will work on the first one, but it won't fix the second one. And the reason that is, here's why that might not work. Actually, I wasn't zoning out on the first time. It did work the first time, but it didn't work the second time, and the reason is because I didn't increase the timer here. So, what happened the first time is when it hit the 12, it jumped immediately. But then the second, because we drew, so we drew essentially 1 second here. This was the first second. We waited a second, but we didn't increase the timer. And then we drew the next second, waited another second, and then increased the timer. And that gives us problems because obviously this is now off by 1 on that first time. But now if we make this 59, we shouldn't see any problems with it at all. And we're kind of coming to the close. Like this is sort of tying off neatly. Because next week, I believe is the last week too. We will actually, we'll go and, well, I've got an idea to implement this into the what we were going to do next week, which was files. Remember how we were going to go onto files there?
Yeah.
Well, I was kind of thinking of implementing this into a way to save it. But if we've only got 1 week, we might just move on to the files and see how we can actually go and write our own documents or save something to a file and then open it again later. So that's what we're going to do next week. And providing it can be done in a week, in one lesson, we will also try and implement a sort of a way to see how we can use files with these, with the turtles as well. But first of all, one little modification is we want to hide these turtles as well. So you want to hide the clock turtle and the minute turtle. So now that those are hidden, those will be hidden. It'll look like an actual clock. And that is everything we actually need to do. We can get rid of that comment there because that's not needed. Now the reason I'll quickly we got a bit over time here, but if I'll quickly explain what this is. The reason we have to do 1 second at the start is because if we drew this second in here at the first time, what we would have to wait a second and then turn them right at the end, and it sort of just it plays with the logic a bit. This actually taking the first second and minute outside of the loop and then starting the loop makes this loop a lot easier to work with, is all it was. So that one's more just you sort of get a feel of it, but with experience. But did that go one early there? Either way, if you tweak this number, you could make it go every 30 seconds, and once it hits the bottom there, it will go, and then once it hits the top, it'll go, and then once it hits the bottom. So you can play with these numbers and see what you can actually make with this. Maybe see if you can also implement an hour hand that's done in almost the same way. Is you can use a timer. You could even work out a way to use this timer. There is maths that can let you use just the one timer to do them all. But if you don't know how to do that, you can always just make another timer and make that go every make that increment once every minute. And because there's 60 minutes in an hour, just add it every 60 times again. So it sort of plays on there, is because they're tied, because there's okay, that did go early. So stick with 60 and change that is all we had to do. Did you have any questions with this?
No.
Okay, so you're have you got all of this?
Yeah.
And you understand what I'm doing. Like, this was all last week, but do you still remember that?
Yeah.
Great. And here we're just using two turtles, so you can do that. Like, you can have two independent turtles and do their own separate things and undo them separately, which is a good show of variables as well. Another thing would be also is to move these up to the top where we make all the variables as well. But actually, I will do that just because and okay. So if you had no questions there, that's the end of the lesson. Now we've created a clock just here. It's not correct. You'll see it'll move pretty soon. But once you run it again with that 60 down there, see how it just moved then. Once you go with 60, it will fix itself up there. That was just a bit of a maths problem. Okay, so I will see you next week where we'll move on to files and how to actually work with them. Yeah, that's really nice. So I hope you have a lovely week.
You too.
And I'll see you next week.
See ya.
See ya.